Okay, awesome. Hello, everyone. Thank you to the BSides team first for giving us this opportunity to present on MCP server security. And thank you for this audience for showing up on a Saturday morning. So a bit about us. I'm Aakansha, and I have a total of 6 years of experience spanning security operations, cloud security engineering, and cloud security architecture. And my focus for the past 2 years have been on AI security. And I'm accompanied by my co-presenter, Navjot.
Hi, everyone. So my name is Navjot. I'm currently working as a cloud security associate architect, having a total of 7 years of experience. My focus areas are cloud security, AI security.
And today we are here not as encyclopedias of MCP server security, but as security professionals who have observed this technology in action and noticed some security risks and want to share our learnings with you in an easy way.
So today we will touch briefly upon the risk associated with the MCP servers and how MCP Gateway can help implement those security controls to mitigate these risks. So as our guides on MCP server security today, we will also have a quick demo where we will also show you MCP server in action, and as well as highlight the risks while explaining the MCP architecture. And then we will also introduce you to the MCP Gateway, highlight its importance, and also show a quick demo there. Then we will also try to understand the different components of MCP Gateway, and finally, how security controls can be implemented via it.
I'm trying to bring up. Just give us a second before we try to switch.
So we're just trying to bring up the demo here on the screen.
Okay. Okay. So hopefully you have seen this screen, and we'll start with a quick demo. And we want to show you what an MCP server looks like in action. So we have built a very simple MCP server which connects to my Gmail account. So it's been granted access to 2 tools. One is list Gmail, and the other is read Gmail. So for demo purposes, I'm using Claude Desktop as my MCP host, but it could literally be just any AI agent or client. So what you can see here now is that we do not have any security controls. We don't have any gateway. So when I asked Claude to show me my recent emails, you would be able to see, because I'm authorized to access my Gmail account, of course, and I did the setup in that way, I'm able to see all my recent emails listed with all the data from my emails. Claude automatically pulls back the entire emails, including sensitive information like account statements, phone numbers, and other personal data. Now, the difference between me reading these emails in Gmail versus accessing them in Claude via an MCP server is that an AI decided to just retrieve that information on my behalf. Now imagine inside an enterprise, Claude Desktop still has some inbuilt security controls. But if it is an in-house built AI agent and it has no security controls, imagine thousands of employees using either these AI assistants or in-house built AI agents and being able to scan sensitive documents, information, query sensitive databases, and access file shares at this machine speed. So this is what we are talking about, and we see this as a huge risk. Every single request here will succeed. If I try to list all 50 emails, probably my AI agent would be able to list them, and it would not validate any request that I send, and there are no audit logs as well. So here is where it even gets worse, and I think Rene covered it beautifully in his talk. What if the tool itself, like read Gmail or list Gmail, was poisoned? What if a developer published a malicious read email tool on the internal registry and attackers swapped it and there was a supply chain attack? What if the model decides to autonomously call that malicious tool because it looked relevant and brought sensitive output and exfiltrated data? So you don't just have data leakage, you have AI-driven exfiltration happening completely autonomously, especially when there is no human in the loop. That's why we think securing MCP traffic matters. And the problem isn't just who is allowed to connect or what, but it is also what these tools can do and how easily can AI be tricked into using them. So, okay, I think we'll just move on to the next slide. Sorry about the interruption. We're trying to switch between. Okay. Okay, now let's learn a bit about MCP if you're not already aware. So before MCP, if your AI assistant wanted to access a database, you had to write custom code, custom APIs, or custom wrappers to access your file systems. So that was a mess to maintain. But MCP standardizes this. One protocol, and any AI agent can use it. Claude Desktop, ChatGPT, anything. You write one MCP server, and everyone can connect. It's, of course, elegant, but as you might know, this is also insecure by design. MCP focuses a lot on functionality, and it is beautiful, but it does not emphasize on security. Just like what you saw in demo 1, I was able to list all the data very easily, and there were no security controls. So just giving a formal definition of MCP, MCP defines a structured way for AI models to request, execute, and exchange data through a client-server model using JSON RPC 2.0 messages over transports like HTTP or STDIO. Let's quickly understand how an agentic solution with an MCP server can typically work. On the left, you can see that we are starting, let's assume that I am the user, and I'm using this Gmail server, MCP server, via Claude Desktop. So I'm sending my query, for example, show me my recent email. The query goes to the LLM, which is the brain of the entire solution, and then the LLM decides that it needs to use an external capability. So it would pick one of the tools, like list Gmail or read email, and then it will ask MCP client which tool can help, and finally it chooses the right tool, and then the MCP server runs that tool, and the MCP client, after sending this request to the MCP server invokes that tool, and finally the tool results in an output, which is sent back through the MCP client. Now, the LLM is generating a human-readable response for the user. LLM is deciding what to do, making it autonomous in nature, and MCP client is handling how to connect, and MCP server is executing the actual tool behind the scenes. So this means that every new tool you expose will become a potential attack surface.
So MCP adoption is exploding. Enterprises, startups, open source communities are racing to build LLM-powered workflows. So there are more than required number of MCP servers in the wild connecting AI agents to the databases, file systems, and APIs. Even though MCP servers in prod are less today, but with the MCP ecosystem booming, we can expect to see more number of MCP servers in prod environments in the coming future. Now, let's talk about the risks. So the first risk here is the arbitrary tool execution. So in this one, so LLM can call any tool without any restrictions. The second one here is the exfiltration of risks. So where the sensitive data leaks through the side channels. The third one here is the untrusted context. So where the user input flows directly to the tools with no sanitization. So fourth one is the zero visibility. So where there is no audit trail, no way to detect abuse. So every one of these ones were presented in the demo, as you saw. MCP dramatically expands the AI, what AI can do, but also dramatically expands the attack surface.
Now let us try to map where these attacks happen in the flow we just saw. So at user input that we saw in the previous diagram, there are prompt injection attacks. Someone tricks the model into calling unauthorized tool. At the tool call level, there is no authorization enforcement. That means the server doesn't check if this request should be allowed. So when we talk about authorization enforcement, we are not just talking about who's allowed to log in, but we are also talking about who's allowed to call what tool, when, and in what context. That's the layer that MCP lacks by default. So in the response that is supplied to the user, sensitive data can leak and there is no audit logging. So there are 4 main choke points and there are 4 opportunities for attack. And MCP protects none of them by default. So the solution that we are proposing, and you've heard this, Zero-Trust architecture. And there are 3 core principles. One is that you authenticate and authorize every single tool call based on identity and context. Second is least privilege. You grant only the minimum permissions that are needed and nothing more. And third is assuming breach. You design your systems like they have already been compromised. Never trust, always verify, and try to minimize the blast radius. And that's what the MCP gateway will help us with.
Okay. So here, our gateway will act as a security proxy that sits between the AI and the MCP servers. So below are some components and features of MCP gateway. So the first one here is the policy enforcement. So this exactly defines which tools can be called and by whom. The second one here is the identity and authorization, so which verifies every request with role-based permissions. So third one here is the schema validation, so which validates and sanitizes every input parameter. And the the fourth one here is observability and logging, which logs everything with full audit trails. And the fifth one here is the isolation, so sandboxed execution with resource limits. And the last one is principle of least privilege, so which scopes down the permissions with per agent and tool. So MCP server behind completely unchanged. You just drop the gateway in the front. So that's the only change.
So let's talk about controls that could be implemented by this MCP gateway. Layer 1 is identity and authentication. At this layer, we will verify who is making the request. So in our demo that you just saw, Claude Desktop was the MCP client, and the gateway would require it to authenticate via an OAuth token or an API key issued by your identity provider, whichever you are using. So if a random unregistered client tries to access the Gmail MCP server, the gateway should immediately block it. Every request that is sent, which is passed via the gateway, has to be tied to an authenticated identity. So think of it like entering this university. The badge is checked before we enter the room. Second one is authorization and policy engine. So once you have verified the identity of the agent, the gateway will check what the agent is allowed to do. For example, in my case, you notice that my agent had 2 tools and the access was granted to list email and read email, but it was not authorized to call delete email, right? So if I were routing my request via an MCP security gateway, then my policy engine would automatically block any request that I make to delete emails. So even if an LLM tries to call a tool it shouldn't, the gateway would deny it even before it reaches the server. The third layer here is schema validation. Now, we also want to check how the request is structured. The gateway validates the parameters which are passed to the tool, things like limits, table IDs, table names, etc. In our Gmail example that you just saw, the models, if the model sends a request to fetch 10,000 emails, but the schema says that the limit is just 100, the gateway has to reject it. So schema validation can not only prevent attacks like prompt injection, but it can also take care of any unrecognized or unsafe parameters and block them. Last layer, which we feel is also very important, is audit logging and observability. Finally, every single approved or denied action is logged with full context. Who called what, from where, when, and what the result was. In the demo with the Cloud Desktop MCP server, we saw that we had zero visibility. Now with Gateway, if someone runs, let's say if we are able to successfully deploy our MCP gateway, and it has policies which will block emails from unknown client, we will be able to detect it in our audit logs, and our security teams can monitor and alert on them. So these are the 4 main layers: identity, authorization, validation, and audit. Together, we can convert MCP to a more trusted protocol and build this MCP security gateway and deploy it in our enterprises. So I've tried to keep some backup slides here. So if my MCP gateway is running, and if I have defined some policies, let's say for my Gmail server, for my MCP agent, which in this case was Claude, if I have defined that I can only do read and list, if I try to execute the command with delete, my MCP gateway should block it, and I should also be able to see audit logs. I want to highlight that there are several open source MCP security gateways available. We can drop links to few of them. You can try experimenting with them and see some of these controls in action. As highlighted before, MCP Gateway will act as your choke point. It will enforce policy, validate requests, and log every action. So your backend servers, your tool registries, and your data sources are all isolated and never exposed directly. Okay, so let's do some risk to control mapping here. We already covered some of it previously, but for prompt injection, the gateway will help intercept malicious prompts using input validation, enforcing policies, and sanitizing any parameters. And then for sensitive data disclosure, we will ensure that the permissions are scoped and the response is redacted so that only safe data is returned. We have seen in some real agentic solutions that we do not want to output PII to the end user. So we can have some of these redaction policies also applied at the gateway layer. Schema validation and boundary enforcement can stop these tools from misbehaving. Then the gateway can use the tool registries, and only approved tools can run. This is to mitigate any supply chain risks that we spoke about. Then RBAC and least privileged scopes can also ensure that agents are not able to call any tools that they are not meant to. And last but not the least, audit logging and alerting will give us full traceability for every request. Now, this is an actual policy file which can enforce some of these rules that we talked about. So we have defined an agent, in this case, the Gmail server, which is authenticated. Now, as you can see, it is explicitly allowed to call only 2 tools. Database, it's only allowed to call 2 tools, list email and get email. And you can also see that we have made sure that we do not allow send, delete, any state change operations. So such kind of policy configurations can help us, and these will act as like RBAC plus schema guards. And as you can see, we can first vet who is calling, then we can see what each agent can use, then we can validate the tools, And finally, we can log every call. So this single YAML file, which is used as an example, defines who can do what with which data and how it's monitored. That's zero trust in practice.
So this is how the real world deployment looks like. So on the left, we have the DMZ tier, so which is a standard parameter control, which has a load balancer, WAF, and API gateway. So in the middle is the security tier, which has that's where the MCP gateway resides. It integrates with auth service, policy engine, and audit logger to enforce zero trust at the MCP layer. So on the right is our backend tier. So this is where the actual MCP server tool registries and data sources reside. So the key principle here is no LLM or agent talks directly to the backend. Every request passes through the MCP gateway for authentication, validation, and logging.
So you have seen the problem and the solution. Now some practical guidance for deploying this in production. So for the policy configuration, we recommend that you start with a default deny, though that may not be liked by your application teams, and you block everything. Then explicitly allow what's needed. You must define granular scopes per agent role, and version control these policy configurations in Git just like you would do your application code, and perform regular audits. For authentication, we are saying generate strong API keys, rotate them every 90 days, so that if a key leaks, it has limited lifetime. Integrate it with your existing identity providers, maybe Okta, Azure AD, or whatever you're already using. We don't think there is a need to build another identity silo, although we may notice that in a lot of organizations. And enforce rate limiting per identity, not just global limits, but per agent, so that one compromised agent cannot exhaust everyone's quota. Logging alone isn't enough. It would be good if you could set up alerts for anomalies. So if someone in your organization tries to call tools that they are not allowed to use, that's recon. So we must deny those patterns, but at the same time, we must have SOC also monitor such kind of activities. Finally, isolation and hardening, defense in depth, run your MCP servers in sandboxes so that if one gets compromised, it cannot affect others. Set resource limits to prevent denial of service, and if you can, possibly red team your MCP servers. Conduct static code scan of your MCP servers, especially the ones that you built in-house. So these 4 areas can turn your proof of concept into a production deployment. The gateway code is open source on GitHub. We'll drop few links, but this checklist can help you get started safely. There is one thing, performance overhead. We have noticed that even with Gen AI gateways that we have deployed, there is some latency observed, and there might be some latency observed with MCP gateway as well, and scaling might be an issue. But I think every organization can cater to it as per their needs.
So quickly, I'll go over the key takeaways, and then we'll close the session. So MCP brings power as well as the risk. Every tool is a potential target. So zero trust is essential. Never trust, always verify, enforce least privilege. The gateway provides defense in depth, policy validation, and isolation and observability with the logging. So here, if you can't secure, it's all what you can see. The solution is open source and production ready. Start building secure AI solution today. But yeah, thank you very much for everyone's attention. And yeah. So we will be on site if anybody has any questions.
Actually, we still have some time. Do you want to field some questions?
Yeah, we can take them.
Yeah. Does anyone have any questions?
Do you see the emerging ways to secure MCP? Do you see different divergences, or is there convergence on an MCP gateway approach?
So I think your question is like, will this approach suit every kind of MCP server?
No, I mean, do you see emerging approaches coming up, like different ideas to the MCP gateway out
There are few open source solutions available, and we can link them here. But this is the one that we have explored, and we have been trying to deploy it in our enterprise environment. Thank you for your question. Yes.
You mentioned the latency when you were talking about the security reference architecture, and I wonder, do you think it's necessary to have MCP? Let's say in the Gmail example, let's say we just used a delegated offlow where we took the user's token and then used that to terminated authorization at the API gateway.
Yeah.
Is that not a more natural solution?
Yes, you're right. So first thing, we could do this without an MCP server, but teams are building it. But I think your question is more around, can we do this via an API gateway, right?
Yeah, so like for instance, like in Renee's presentation, we said if you treat agents like users,
Yes.
right? So we just take the user's token and then use that to terminate authorization, determine if you're able to read those mails, and just do that at the API gateway instead of using MCP.
Yes and no. So API gateway can be a possible solution for some of these. But if you notice in API gateway, you are mostly reading the headers. But here, we are also recommending that you read the payload and the context also, which comes with it. So an MCP gateway is recommended approach. But you are right. It can be done via an API gateway too. Thank you for your
I
question.
think there was one question there. Somebody has a question there as well, or okay, yeah.
Kind of on the same lines. I was thinking in terms of the security gateways that we have with AWS and GCP. And
Okay.
also to ask, in your official opinion, how soon do you think these will become more of a norm within the existing cloud architectures? And I'm thinking in terms of the overhead of us setting these up and then the companies coming up with a solution of their own that kind of interoperates with the existing gateways that also ties in with MCP architectures. So is it worth building these out as secure as it is?
So what we have noticed, at least in our organization, and ours is a large one with more than like 25,000 employees, so that gives you the scale. And we ship agentic solutions every now and then. So when we started with just the model endpoint usage, we developed our in-house like AI gateway. Of course, we deployed it on the cloud and we used Azure for it. But you're right, it will become the norm. And we also expect that for MCP server security, at least in our company, we see these servers being spinned up left and right and being deployed to production. And that's why we thought, because for some of the use cases, visibility is so less that it becomes important to have gateways like these. And we are already working on like implementing it in our company. Maybe organizations would build it in-house, and I don't think with help of AI, it's as difficult today to build your own. But if you want to use open source or vendor-provided solutions, I think you could do that. But to your question, would it become the norm? We think it would be, but then our knowledge is just limited to our company, right? But thanks for your question. Yeah.
In your configuration file, you have an allow list and a deny list.
Yes.
Why the deny list? Why not just automatically deny everything?
So we don't want to deny. You can if you want to.
You're allowed to call.
Yeah.
Why specifically deny? Why not just say that this is what you're allowed to do, all the rest are?
Yeah, you can follow that approach too, if that works. It depends on, because in some of the organizations, it's not easy to just have explicit deny and then allow. So it depends on what threat model you have. And if you can do an explicit deny, I think that also works.